Good morning, my students, those near and far. Afternoon, something. So I'm going to be working on a series of word problem videos. The first thing we have on the screen here is the problem-solving strategy, copied from your college algebra book. If you ever click on any of the explanations in ALEKS, it may reference this, so I'm just providing it as a reference. Do want to highlight some things from it. So read the problem carefully and determine what the problem is asking for. What the problem is asking for most of the time is going to be your variable, if the problem can be written in terms of only one variable. So a lot of times I like to make that X if picking other letters doesn't seem appropriate. All right, here, draw a drawing or some sort of table to organize your information. Write it down. They really should say and the units. I find if you leave off the units, like stuff gets lost, and sometimes the units can actually help you figure out what to do. And then a lot of times there's going to be a formula that we use that we're going to fill in the pieces that we know or we have created labels for, and then we'll have an equation to solve and interpret the solution. So this is see if your answer makes sense. So if I ask you to figure out the price to set for DVD players, -22 is not a real price. It's a perfectly real number, but it is not a number that makes sense when I'm asking you to set a price and you tell me a negative. So even if you do a whole bunch of work, you get to the end and you're like, that's not right. Box it and say, this is not right because, and I will give you credit for realizing you made a mistake, even if you can't find the mistake. I'm going to try to do the midtermers part take home though, so hopefully if you get stuck, you can ask. All right, first big skill is talking about translating. Math is a foreign language, regardless of what English people think. I say this because here's the big problem with word problems. I read a word problem and it sounds clunky. The editor would look at it and say, no, you don't need to say it like this. Here, rearrange this, put this up front, there. Much more concise and pretty. And I look at it and say, you totally screwed up the math. So sometimes the editor's the last person who gets a hold of the problem. And it reads nice, but it doesn't translate nicely. So here's 3 statements to give you an idea of what I'm talking about. 5 years ago, Bud was half as old as Eric. This is a perfectly normal statement. I mean, math normal. But to interpret what this means, there's some confusion. So is it only Bud's age 5 years ago, but Eric's age now, or was it also Eric's age 5 years ago? I don't know. And that vagueness makes for bad math. A little bit better would be 5 years ago, Bud was half as old as Eric was. So now I've put that was on there to indicate I'm talking about Eric's past age as well. But it's still a little vague. Like the mathematician in me is like, I don't like this. And the English person would be like, you put a verb at the end. No. So here's what the mathematician would write. Bud, 5 years ago, was half as old as Eric was 5 years ago. So it sounds redundant because we're saying 5 years ago twice. But the redundancy makes sure that what I'm trying to say is clear. So let's try this one out here. We're going to translate this crazy sentence here into an equation. So it starts with, if 6 less than a number is tripled, the result is 5 more than the number. Find the number. All right, so this first sentence, like, reads really awkwardly and clunky, that means it's still in math, and that means we can translate it very literally. So if 6, I know 6, that's the number 6, less than, now this is a, do they mean the less than symbol? Or do they mean subtraction? So let's expand a little more. 6 less than a number. So that's subtraction because we're doing whatever our number is, say 10, and then I go 6 less than that and I get 4. All right, so our number, you could go with X. A lot of times I will use variables that very much relate to the thing we're naming. So since this is a number, I often call it N. And I'm going with a capital N because my lowercase n's look weird sometimes. So 6 less than a number would be the number minus 6. All right. So number 6 less than. And then it says is tripled. All right. So earlier I said 6 less than 10 would be 4. So if I say if 4 is tripled, brain should come up with, oh, that's multiplied by 3. So if this other crazy thing is tripled, we're going to do times 3, or you could write times 3 after the parentheses. It doesn't matter where. I just habitually put stuff in the front. So if this thing, there's an implied then, the result is 5 more than the number. So if I do 6 less than the number and triple it, then the result, meaning that thing, is, so our verb in the sentence is where our equal sign goes. Is, has, was, costs the same as, that's where it goes. So the result here from our English sentence structure is referring back to the thing we just translated. So that's why I know the equal sign is going to go between these. And then the last part, 5 more than, I know more than, let's add the number. So you can write 5 plus n or n plus 5. And Alex should be pretty good about taking both answers. If they ask you to type the equation, as long as your letters are probably all need to be capitalized. Usually what they will do though is they will tell you the variable to use if they want you to type in any sort of expression like this. So be on the lookout because it's really easy to overlook the variable because it's just written in a normal line. Now, we can take and solve this, which I will go ahead and do real quick, but it's going to be real quick. So we're going to distribute 3n's minus 18 now. Still n plus 5 over here. In order to solve, I want my variables together. Since I have more n's on the left, I'm going to choose to cancel the n on the right. So 3n minus n does not become 3. If it helps, you can sketch the 1 back in. 3n's minus 1n is 2n's. And then n minus n here, though, 1n minus 1n is 0n's, so I don't even have to write it. 0 plus 5 would be 5. All right. Then we're going to take 18 and add that over. In our quest to get the variable, we got them all together. Now we have to get it alone. And my hesitation earlier was realizing this did not say integer, it said number. So we're not guaranteed to get a integer answer. Normally these are integers, but a lot of times if they expect an integer, they'll tell you. So now it is 2n's is equal to 23. Then we would divide by 2. 2 times n, the opposite of multiplying is dividing, to leave us n on its own. And 2 goes into 22 at least 11 times. With 1 left over, 1/2 would be 0.5. I'm only going with a decimal here just so you get a sense for where the number is approximately. And you can check so this answer makes sense. That doesn't mean you have to write the whole step out. I am not that picky. But if I did a calculator, 11.5 minus 6, 5.5, and I did 5.5 times 3, I'd get 15 plus 1.5, so it'd be 16.5. If I take 11.5 and add 5, that would be 16.5. So I got the same number on both sides, so that is indeed the solution. Any equation, as long as you've constructed the correct equation, you can check your answer by substituting it back into the original. You could also take the answer and just run it through the problem as it's stated and see if it all calculates out and it makes sense. You just read 11.5 in place of the number and then do the calculations that it tells you to. All right, so I'm going to stop this one and start a new one.